Thank you for attending. Today's presentation will begin shortly. Hello, everyone. My name is Thomas Cummins. I'm a Partner Solutions Architect at AWS, and along with Manuel Holfelder, Manager of Emerging Applications at Infineon, and Andrew Mazur, the CTO of Klika Tech, we're here to present an AWS IoT partner solution for Industrial IoT, focusing on predictive maintenance. So Infineon and Klika Tech are AWS partners, and they have put together today's solution, which we'll be getting into. So in today's webinar, we'll be going through a brief introduction of AWS IoT services. We'll then be transitioning over to the Infineon and Klika Tech teams to provide an overview of their predictive maintenance solution and actually provide a demo of their HVACR demo. And then we'll be getting into the AWS IoT partner community capabilities. And then we'll wrap up with some call to actions and some abilities for you to follow up with Infineon and Klika Tech on this solution, and also learn more about AWS IoT services. So before we begin, let me provide a brief overview of the AWS IoT offering of our services. And we sort of break these down into three general categories. We have device software, so software running on IoT devices out in the field. And this is designed to run on anything from embedded microcontrollers using FreeRTOS and our FreeRTOS libraries to industrial PCs and edge gateways, which can run services like AWS IoT Greengrass. We have connectivity and control services, which are the services used to control and connect with and manage devices out in the field. So these include AWS IoT Core, which I'll be getting into in a little bit. And then we have our analytics services, which are services that are used to aggregate, ingest, process, and deliver value on the IoT data that's gathered. So we have our AWS IoT services, and then along with our rich AWS partner network, we work with our partners closely to develop IoT solutions for our customers. And so today is an example of Klika Tech and Infineon coming together and working alongside AWS to develop a predictive maintenance solution for our industrial IoT applications. So first, we'll take a look at some device software offerings that we have, and in specific, we will look at FreeRTOS. And so before we get into that offering, briefly, we look at IoT devices out in the world that generally are running either microcontrollers or microprocessors. And so we provide software for these devices to securely connect both locally to edge gateways and then also directly to the cloud to our cloud IoT services. And so the first question is, if you have microcontroller-based devices, how can those securely connect to AWS IoT services? So now we'll take a look at how we can connect microcontroller-based devices directly to the cloud and our AWS IoT services. So we have partnered with the FreeRTOS community. FreeRTOS is a trusted and open source real-time operating system that's used in many applications all around the world. And we have actually developed a number of FreeRTOS libraries that provide secure connectivity to our AWS IoT services. So this includes local connectivity if you want to connect microcontrollers to edge gateways that are running AWS IoT Greengrass, cloud connectivity if you want to connect microcontrollers directly to the AWS cloud, to AWS IoT Core, for example. Security is built in. TLS 1.2 is used for all communication. And there is OTA and code signing capabilities that are packaged within these FreeRTOS libraries. And so briefly, I'm going to cover AWS IoT Core, another one of our AWS IoT services that is in the connectivity and control services group. And so AWS IoT Core is one of the core services of our AWS IoT service portfolio. It offers a range of core functionality that you need for developing IoT applications. It has the ability to manage connections securely with millions of IoT devices out in the field. It has the ability to manage the routing of millions and millions of messages coming through its broker. It has the ability to manage the communication of devices that may have intermittent connectivity and the state or the connectivity state is going on and off. And then it also is highly integrated with the rest of our AWS services, making building applications much simpler. So a few key capabilities of AWS IoT Core is the device gateway, so the ability for devices out in the field to securely connect to AWS IoT Core. Our identity service is the ability to manage the identities of each individual device out in the field. We use things like X509 certificates and specific scoped IAM policies to control the access of every single IoT device out in the field and what resources they can consume and connect to in AWS. The message broker is an MQTT broker, which can handle massive amounts of traffic and routing of messages over MQTT topics. The rules engine is a built-in capability to execute business logic on all the messages coming into the message broker. And these rules have native integrations with the rest of our IoT services, including Kinesis data streams, DynamoDB, S3, and the rest of our IoT services, including IoT events, IoT Sitewise. Device shadow is the ability to synchronize state between virtual things in the cloud and physical things out in the field. So if there is intermittent device connectivity, IoT Core can maintain that state through the device shadow. And when there is updates from that device out in the field, that state can be synchronized up in the cloud. And that service manages all that. And then finally, the device registry. So this is a registry of all devices you would have out in the field, and you have the ability to assign attributes to these devices, group them into groups where you want to perform jobs on them. For example, you want to roll out OTA updates to only a certain segment of your device fleets out in the field. So these are some of the key features of IoT Core, and IoT Core is one of the key services that is being used in the demo that we'll be taking a look at today, built by Klika Tech and Infineon. And with that, I would like to hand it over to Andrew Mazur of Klika Tech to provide an overview of their HVACR solution.
Thank you, Thomas. So in partnership with Infineon and AWS, we've created a generic solution for various industrial sectors. So it helps to optimize the operation and the maintenance of the physical devices and assets. And the basis of this solution is a sensor data that can show us what is the current state of the device. So later on, we can use this process data to monitor the current state of the physical asset, detect different anomalies, and even predict future failures. One of the applicable fields for this solution is HVACR industry, and it is beneficial for every HVACR owner to get insights on its equipment before it causes a heavy damage, before the failures cause a heavy damage. And according to the statistics that we gathered from different HVACR service organizations, the most common failures are within the compressor and air exchange fans. And in order to demonstrate the condition monitoring and also anomaly detection within the HVACR, we created a special demonstrator, and we'll showcase it a bit later today. So the next logical step for this demonstrator is to implement a predictive maintenance feature. And it can be done after gathering gathering data from different HVACR units of the same model before they get broken. And it's a quite complex task and time-consuming task, and it also should be done separately for each model of a specific HVACR manufacturer. And when the data is gathered, we can train a predictive maintenance machine learning model that will in future just show us the predictions, and we will, with this help of this trained machine learning model, inference the future failures of our HVACR system. Let's move to another slide. Here, we would like to talk about the example architecture of HVACR demonstrator that we'll be showing today. And as you can see, here we have a portable HVACR unit Then we also have Infineon sensors and Infineon MCU that we attach to the HVACR unit. On the right part of this diagram, we can see AWS-based solution for the data processing. And also we have a small data visualization application that is part of AWS services, and we will showcase it also today a bit later. So the raw data is collected from the sensors that are attached to the HVACR and processed on the edge by Infineon XMC 4700 together with FreeRTOS. So FreeRTOS powers the hardware. Later on, this data is wrapped into the MQTT messages that are being sent to AWS IoT Core. And as Thomas has mentioned, it is the main data ingest service for the IoT devices. It has an MQTT broker that accepts all the incoming messages. Later on, we utilize AWS IoT rules service that just propagates the incoming data to other different AWS services. So later on, we push data to Kinesis data streams, and there are several consumers of these data streams. First of all, we use Kinesis data analytics that has a built-in anomaly detection algorithm that is called random cut forest. So this data is being processed, and AWS Kinesis data analytics help us to just figure out the anomalies in the data sets. Then found anomalies we sent to yet another Kinesis data Firehouse service that shifts the data to Elastic Search Service that has a front end, so-called Kibana, where we see the anomalies that were detected by the system. Also, we have another consumer of the data stream from Kinesis data streams. We just process all the data and store it in the S3 for future use while we will train the machine learning predictive maintenance models. Also, you can see here that we utilize AWS Cognita. We use this service to grant proper permissions, access permissions to our dashboard. We also use CloudFormation and AWS CDK to bootstrap the overall infrastructure. And we use additional service to work with logs and debug informations with CloudTrail and also CloudWatch. I would like to note that in this specific implementation, we support the bidirectional data flow. So we can not only send the data to the cloud, but we can send the data from the cloud to our HVACR device. And based on this feature, we can also control the HVACR remotely. We can change its configuration or even update the firmware over the air. On this slide, we can see our demonstrator that we have chosen. It's a portable HVACR unit, and we chose it only for demonstration purposes because of its mobility. So it has the same structure as all other HVACR types. And within our demonstrator, we monitor the compressor and air exchange fans, and they are indicated on this slide. So you can see the cold fan output and the cold fan out input, also with the hot fan output and the compressor. And after this slide, we will show you a video where you will see the data that comes in the graphs. So this data is and this graph is meshed together with the video that we have recorded. So on the top two graphs, you will see the anomaly score that is being found in real time by the system after the data that is sent from the HVACR utilizing Infineon sensors to the AWS. Let's move to the video. Okay, so on the video, you will see that there is also a recording of our demo HVACR together with different graphs. And on the top two graphs, you can see the data that is of our interest. On the left top graph, we visualize the anomaly score that is calculated at this specific moment. And the right top graph shows us the time series data of the anomaly scores that have been calculated before. And when the values on the both graphs are in the green zone, then the HVACR behaves as expected. And on the other hand, when the data on the graphs is visualized in the red zone, then the anomaly has been detected by the system. Being that said, let's switch on the video and you'll see everything in real time. So first of all, we'll show the compressor anomaly behavior. At the beginning, you see that HVACR unit operates as expected. Now we're switching on the heating element that is connected to the HVACR, and you see that anomalies are being detected. That's due to the fact that the current consumption is increased, and now we've switched the heating element off, and you'll see that right now HVACR operates as expected. Then in a second, we'll move to the fan animal behavior video. It is similar to the one that we've showed with the current consumption. And as you can see, the HVACR operates as expected. And now we will emulate the situation when the fan is dusty. And we close the fan with an obstacle, and the same random cut forest algorithm identifies that there is an anomaly, and it is visualized on the upper graphs. Okay, let's move to the other slide. On this slide, we would like to describe the hardware that we use in our solution. So first of all, we use Infineon XMC 4700 MCU. It is based on ARM Cortex-M at 144 megahertz. So the board has 2 megabytes of flash and 352 kilobytes of RAM. So the chip is also equipped for an extended temperature range up to 125 degrees Celsius. And there are many different additional advantages, but I would like to mention that it has a long-term availability through 2031 or longer. For the internet connectivity, we use a Wi-Fi module. Then I would like to tell a few words about the Optiga Trust M. So as an embedded systems are increasingly gaining the attention of attackers, Infineon offers us Optiga Trust M solution for different industrial systems. And here we utilize this in our HVACR solution. This is a high-end security controller, and it comes with different kind of system integration supports, also including free RTOS. And I would like to mention that it is a cost-effective solution. So where we use it, it really enhances our overall system security. So we use it for storing AWS keys in a secure manner, and it prevents leakage of the keys even after the physical access to the device. So even when it's tampered, we make sure that our keys are stored in a secure fashion. And we utilize these keys to securely connect to the AWS IoT core or the TLS. So in this case, the channel between the HVACR and AWS is secured. Let's move to the sensors. We use several current sensors. One is for measuring the consumed power by the compressor, another measuring the current consumed by the fan. And when the average consumed current changes significantly, as we saw it on the video, it means that something went wrong. And with the motor or the filter, and hopefully in the future we need to change the compressor. Then we use several air temperature and pressure sensors. And one is used to measure the compressor temperature, which should be in an acceptable range. If not, it means also that the compressor should be considered as near to fail. We use another temperature sensor to measure the temperature that is coming out of the fan. So in the case when the cooling system of the HVACR works as expected, we get the values around 0 degrees Celsius in the output fan. And we get the 40 degrees Celsius for the hot outlet. And this sensor, this temperature and pressure sensor has an outstanding characteristics in measuring the pressure. So as fans make air blowing, it increases the pressure on the sensor relatively to the atmospheric one. And in this case, we can add additional business logic where we can compare these values in a time manner and check whether the fan is blowing or not. Also, in our solution, we use a linear Hall sensor. It is an analog sensor which is fixed near to the compressor body, but it has no mechanical connection with it. It is an analog sensor which is used to sense the magnetic field which vibes because of the compressor vibration. And the spectrum of the signal is pretty clean. And then we can state that the compressor works as expected. And if not, if this data is dirty and full of different harmonics, it means that there are the problems and we can face such situations when there is for example, unscrewed nut. The last hardware sensor that we use is the microphone. It is a highly dynamic range microphone from Infineon, and we use it to record the sound inside the HVACR body. In physics, the sound spectrum analysis helps us to detect many different failures in the HVACR. But we need to state that due to government laws, it can be prohibited to use the microphone inside of the HVACR or any other asset. Okay, let's move on and go to the next slide where we would like to show the architecture of our development kit that we have created together with Infineon and AWS. Here you can see that there is an extended part of AWS services. They are used specially for implementing the last predictive maintenance step. Here you can see that with the help of Amazon SageMaker, we are able to train and educate our machine learning models. After that, after the education of this model, we can utilize them for the inference. And we can predict, for example, what component of the HVACR system will fail in the near future or when a specific component will fail. So this can be done with the help of the supervised machine learning models and special tuned for the predictive maintenance use cases. And that being said, I would like to hand to Manuel to tell us more about the Infineon products.
Thank you very much, Andrew, for presenting the solution for condition monitoring and predictive maintenance. As you already mentioned, you are using microphone and pressure sensor as part of the solution. I'd like also to quickly tell you that the unique feature of our microphones and pressure sensors are, on the one hand, no distortions and crystal clear audio signals on the one hand for microphones. On the other hand, for a pressure sensor, we have a best-in-class solution so that you can get out of pressure changes, altitude changes down to 3 to 5 centimeters. But overall, it's also about an extensive set of sensors which we are using and providing. And as also to mention our environmental sensors to measure CO2, which is also, of course, part of condition monitoring for HVACR devices. Overall, we strongly believe in smart ears, smart feeling, and smart nose for devices in the field. But we also have 3D radar with highest energy efficiency, which can be used for vibration monitoring as well, or presence detection, and our 3D time of flight solutions with best-in-class resolution for 3D mapping and authentication. Here, we also have smart eyes and even the sixth sense to give HVACR devices and also devices in the field these kind of senses. Overall, also we have magnetic and current sensors for IoT solutions, but also with connectivity and RF, we are enabling 5G and also other means of connectivity. As also said by Andrew, part of this solution was also our XMC microcontroller. Also here, we have not only specific industrial microcontrollers, but also microcontrollers for functional safety, which provide the best choice for implementing condition monitoring and predictive maintenance as part of HVACR. HVACR devices. And also, of course, said earlier, embedded security plays an important role to have authentication and encryption from the edge to the cloud. Together also with the right power IC solutions. So it's not only about sensing in the devices, but also about powering them and getting additional insights in the power consumption and into the power supply. Overall, what we see is, of course, showing earlier, we were implementing not only sensor solution and microcontrollers, but overall it's also about linking and strengthening the link between the real and the digital world. HVACR devices are examples for real-world applications, along with other applications like Industrial IoT, Consumer IoT, drives, or power supplies. Here, together with a software ecosystem following the circle of sense, compute, actuate in a secure environment and connectivity, we can link these kind of devices to the digital world. And thanks to the Cypress portfolio, the type of connectivity is also extended to Wi-Fi and Bluetooth solutions, which we are providing here for making smarter HVACR equipment of tomorrow. But of course, it's also very important to mention that such kind of solution can not only be made with semiconductor solutions and components. Infineon, as a component maker, is directly at the beginning of a complex and long value chain from a component maker to a facility owner who in the end runs an HVACR device. Overall, components are integrated to modules with system integrators integrated into the HVACR devices, which itself integrate into building management platforms, and together with cloud providers, contractor and building integrator, and architecture firms, they eventually become part of a building. This is a reason why Infineon, with its security, sensor, and power hardware expertise and its strong footprint powering HVACR devices, decided to partner up along the value chain with Klika Tech for system integration and software for condition monitoring and predictive maintenance, and with AWS for the cloud infrastructure and cloud intelligence. And together with our partners, we are preparing right now an evaluation kit, which is in development as an end-to-end solution to quickly enable condition monitoring on your side. If you'd like to get more information, please contact us. And with this, I'd like to hand it back over to Thomas Cummings from AWS to conclude the session. Thank you very much.
And thank you everybody for attending today's webinar on predictive maintenance solutions built by our AWS IoT partners. To learn more about this specific predictive maintenance solution, please contact Manuel Hollfelder at Infineon and Andrew Mazur at Klika Tech. You can visit the Infineon and Klika Tech booths to get access to this deck that we presented today and be able to learn more about our AWS IoT services listed below there. So thank you again for your time today.